a just right star, you need just right planetary partners. Literally, every one of the 8 planets in our solar system plays a crucial role in making advanced life possible here on planet Earth. So, for example, when our family celebrates Thanksgiving, we thank God for Venus, we thank God for Neptune, we thank God for Saturn, we thank God for all the planets. Because without them, we wouldn't be able to enjoy our Thanksgiving dinner. And of course, we need a just right Earth, and 20 different features of the moon, for example, must be fine-tuned in order for advanced life to be possible on our planet. Now, unlike the universe, we have lots of galaxy clusters to look at. Lots of galaxies, 200 billion galaxies, lots of stars that we can check out, which allows us to make a statistical test of the biblical creation model. So, for example, if there were no creator behind all this evidence, we would expect that these design evidences would decrease both in the number of features showing design and in the strength of the fine-tuning evidence. And we expect that the evidence for the biblical God as designer would get progressively weaker and weaker as we learn more and more about the universe. But what if it is the creator God of the Bible? We would predict the exact opposite, that the design evidences would increase in strength and number, and evidence for the biblical God as designer would get progressively stronger with respect to time. Now, we began this research project back in January of 1995, and at that time, taking note of the dependency factors amongst these features and the maximum number of planets in the observable universe, I told the audience last night that I had the privilege of taking a short course from Carl Sagan, where he claimed there might be as many as 10 to the 23 planets in the universe. I said, fine, I'll take that optimistic number. Even then, the probability of all 41 features of our galaxy, cluster of galaxies, solar system, etc. being met so that one body would possess all of the features necessary to make life possible without invoking the intervention from the creator of the universe was less than 1 chance in 10 to the 31st power. Now that was 1995. If you go up to the year 2000, we now have 128 documented features that must be fine-tuned. Now the probability is less than 1 chance in 10 to the 144th power. And you jump up to 2006, 676 different features. And by the way, this table is not targeting advanced life. This is what they need just to have a planet with bacteria able to exist for at least 3 billion years. 676 different features would have to be fine-tuned, and now the probability is less than 1 chance in 10 to the 556th power. And again, this is documented in that compendium on our website. Now, Freeman Dyson, a theoretical physicist who describes himself at different times as an atheist, other times as an agnostic, wrote a book where he said this: the more I examine the universe, the more evidence I find that the universe in some sense must have known we were coming. The universe literally was designed in advance for the appearance of human beings. And here's another statistical test we can propose. If there isn't a creator behind all this, we would expect that astronomers will find many systems capable of sustaining advanced life, just like the Milky Way galaxy, just like our sun, our moon, and Earth's planetary partners. Indeed, a lot of my colleagues are spending their careers trying to search for Earth-like planets, trying to search for a solar twin and a galaxy just like our Milky Way, convinced that there's no intelligent designer behind all of this. But if we really are talking the creator God of the Bible, we would anticipate that the Milky Way galaxy, our star, the moon, the Earth, and Earth's planetary partners would prove to be unique in their capacity to sustain advanced life. Well, we're now in a position in the 21st century to test these two different theories of life here on planet Earth. Now, we have the telescope power to actually look at thousands of galaxies that are similar to our galaxy. We already know that advanced life is only possible on a large spiral galaxy. And today we can examine in some detail thousands of large spiral galaxies. But of all the galaxies we've looked at, we have yet to find an adequate twin of the Milky Way. It's the only spiral galaxy that we observe that's got adequately symmetrical spiral arms, where the galaxy is the just right size, where the spiral arms are separated by the just right amount, where we have the least amount of warping in the spiral arms, and just the right feathering features in between the spiral arms. Now, we'd like to be able to observe millions of galaxies, but we don't yet have the telescope power to do that. But we already have the telescope power to observe millions of stars in our Milky Way galaxy to see if any of them are twins of our star, the Sun. In fact, there's a number of astronomers, in fact, 2 who have spent over 50 years trying to search for a twin of the Sun. And what's interesting is we have found stars that are twins of one another. But when it comes to the Sun, it has no twin. We can't find a single star that has features sufficiently close to the Sun that it would be a candidate to have a planet orbiting it with the possibility to sustain advanced life. Now, what about planets? Well, as of this morning, we now have 864 discovered and measured planets outside of our solar system. And of those planets, not a single one has the characteristics of any of the planets in our solar system. Not only we're not finding a twin of the Earth, we're not finding a twin of Neptune, we're not finding a twin of Saturn or Jupiter or Uranus. The closest we've found is this particular object, where it comes fairly close to Jupiter's size and orbit. So, for example, Upsilon Andromeda E has a mass that's about 6% more than that of Jupiter's. Its distance from its star is quite similar to that of Jupiter's from our Sun, and the shape of its orbit is similar. And so people have said, hey, this is finally a proven twin of one of the solar system's planets. But it's not really a twin of Jupiter. One of the features of Jupiter is that it's the largest planet in the solar system. Upsilon Andromeda E is not the largest planet in that particular system. In fact, there are 2 other stars, C and D, that are much bigger. C comes in at 14.5 times the mass of Jupiter, and D has 10 times the mass of Jupiter. And notice that both of them are orbiting their star much more closely than Jupiter orbits our star. And when you've got an orbit that close with that much mass, it's guaranteed to gravitationally disturb the orbit of any possible planet with a capacity to support life upon it. So it's still the case that there are 0 candidates of planets outside of our solar system. We've yet to find a single planetary system that would be a candidate for sustaining advanced life. Now, when it comes to moons, we can only observe moons in our solar system, but we've found 178 moons in our solar system. But one of the unique features of our moon is that it's very massive compared to the mass of its planet. Our moon is not the biggest moon in the solar system, but it's by far the biggest moon compared to the mass of its planet. How much? By a factor of 50 times. Compared to the mass of its planet, it's 50 times more massive than any other planet in our solar system. And that's because it's not a true moon. As I'm going to explain in my second lecture this afternoon, our moon is special and it had a unique formation pathway. And because it is so massive compared to the Earth, it stabilizes the tilt of our rotation axis. The other planets have rotation axes that flip back and forth. Ours is held nice and stable because of the moon. And because of the moon's mass, we also have the ideal tidal interaction that makes life abundant on our planet. Hey, if you want to read more about this, you can get a book. This is now in the 3rd edition, The Creator and the Cosmos, where we document a lot of this astronomical evidence for God. And then there's a second book out, also in the 3rd edition, Beyond the Cosmos, where we talk about what physics is able to teach us about the characteristics of the God beyond space and time. But let me spend a few minutes also talking about what astronomy is able to reveal to us about the origin of life. Now, when it comes to biological evolution, and whenever I engage evolutionists at a biological level, I say your easiest problem to solve is the origin of life. Because with the origin of life, we're talking about physics and chemistry producing the first living organism. Nothing could be simpler for the evolutionists to solve. But the truth is, when I debate these evolutionists, they always say, origin of life, I want to pass on that one. Let's talk about the fossil record. I say, well, hey, now you're talking about something orders of magnitude more complex. What about the origin of life? Okay, a couple of things we've learned about the origin of life. Well, I mentioned earlier that I had Carl Sagan briefly as a professor, and he had the following origin of life model, that life naturally arose in a vast sea of concentrated prebiotics that percolated for nearly 1 billion years. You know, when I took that course, astronomers and physicists were aware the planet Earth started off as a water world with no continents. And so his model was that all the oceans of the Earth were packed with these prebiotics, and they kind of jiggled against one another, and over the course of 1 billion years, these molecules will self-assemble into an organism. But we know two things from research since those days. Number one, we now know it's not 1 billion years, that the origin of life happens in a geologic instant of time. Say, how do you know that? We know it because of research done in what's called the late heavy bombardment. That if you actually look at the early history of the solar system, you've got the gas giant planets slowly migrating outward. But we have Saturn migrating at a faster rate than Jupiter. And there reaches a point where Jupiter makes exactly 2 orbits about the Sun for every single orbit of Saturn. That's what astronomers call a 1-2 resonance. Quite destructive. And what that 1-2 resonance did was destabilize the Kuiper belt of asteroids and comets and caused a massive rush of these asteroids and comets to come into the inner solar system. And so there was a peak bombardment of the Earth that took place 3.87 billion years ago. Say, how do you know that? Where are the craters? Well, Earth has such aggressive geology that the craters have all been worn away. But they've not been worn away on our moon, or Mercury, or Mars. For example, if you were to look tonight at the moon, and you'll be able to actually see with telescopes that the craters are very slightly eroded, because the moon has a very tiny atmosphere and a slow rotation rate. And the weathering of the moon's craters tells us that more than 90% of the moon's craters occurred 3.87 billion years ago. We get the same result when we look at the craters of Mercury, 3.87 billion years ago, and also with Mars. And now we've got theoretical models of this Jupiter-Saturn event that also tells us 3.87 billion years ago. But we have the signatures, isotope signatures for life existing over our planet that go back 3.83 billion years ago. You say, what's taking place here? Well, life compared to non-life prefers carbon-12 over carbon-13. So when we look at ancient carbonaceous material in the crust of the Earth, we can measure the carbon-12 to carbon-13 ratio to see if that carbonaceous material is prebiotic or postbiotic. The isotope ratio tells us it's all postbiotic, none of it is prebiotic. We can do that test again with sulfur-32 to sulfur-34. Life prefers sulfur-32. And likewise, life prefers nitrogen-14 over nitrogen-15. And in all 3 cases, it tells us that prebiotics never existed on the face of the Earth, and that life was abundant on the Earth at 3.83 billion years ago. The very moment that we have liquid water and solid rocks on the face of the Earth, we have life. It happens immediately. And based on the late heavy bombardment model, we can calculate it would take 40 million years for the Earth to cool sufficiently that liquid water and rocks would appear. Well, take 3.87, subtract off 40 million years, what do you get? 3.83. Well, we have the signatures for life on planet Earth dating back to 3.83. If you take 3.83 and subtract 3.83, that gives you the time window for the origin of life. That's why physicists conclude the origin of life on planet Earth occurred in a geologic instant. It's literally zero time to the best of our measurements. And because we only see the signatures of prebiotics and not postbiotics, that tells us not only was there no time, Earth never had a prebiotic soup. Just to review here, no time, no soup. Whoops, what's happening here? Come on. Oh, here we go. I'm going backwards. Sorry about that. Oh yeah, these are the signatures that Earth never had prebiotics. And today, we know why Earth never had any prebiotics. It's called the oxygen ultraviolet paradox. Some of you probably remember back to your high school days where they talked about the Urey-Miller experiment, where they put chemicals inside a flask and then put a spark through it, and they got glycine, the simplest of the amino acids, and very small amounts of a few other amino acids being the building blocks of proteins, and they announced that they had solved the origin of life problem. But if you actually read the details of that experiment, they made scrupulously sure there was no oxygen in the flask. The tiniest amount of oxygen stops the prebiotic chemistry. However, in terms of the Earth, if you don't have oxygen in the early Earth's environment, there's nothing to stop ultraviolet radiation coming in from the sun. That was the second thing they made certain of in that flask experiment: no ultraviolet radiation. Ultraviolet radiation is just as catastrophic to prebiotic chemistry as oxygen is. So this is the conundrum. If the early Earth had oxygen, that stops prebiotic chemistry in its tracks. If it doesn't have oxygen, ultraviolet radiation comes through, and that too stops prebiotic chemistry in its tracks. If you got oxygen, it can't happen. If you don't have oxygen, it can't happen. Now, if you have no time for the origin of life, and you have no building blocks for the origin of life, you have no naturalistic model for the origin of life. And you can see this documented in the book that Fuzrana and I wrote, Origins of Life. Now let me finish up here with just a couple of minutes on the origin of humanity. And the story here from an evolutionary perspective is that you begin with bacteria and you end up with human beings, all through Darwinian evolutionary principles. But it was a famous Darwinist who calculated that if you start with bacteria, what is the probability you'll wind up with human beings? Now actually, he did this presentation in front of an audience of astronomers that were searching for extraterrestrial intelligent life in the universe. And basically what he's doing is taking Darwinian principles at the most optimistic level any Darwinist has ever imagined, and calculated that if you begin with bacteria, the probability of winding up with the equivalent of human beings was less than 1 chance in 10 to the 1 millionth power. And the point he was making is Darwinian principles always favor simplicity over complexity. And the problem with starting bacteria and trying to get human beings is you're always going to more complex steps. And therefore you get a very tiny probability that beginning with bacteria, you'd wind up with human beings. In fact, he said with a probability that small, we know it's impossible for intelligent life to exist elsewhere in the universe. Now, it was 3 physicists who jumped in and corrected Francisco Ayala and said, Francisco, you forgot to take into effect the fact that conditions in the solar system change over time. The sun gets brighter and brighter. Radioactivity changes. The moon's influence on the Earth changes over time. Our rotation rate today is about 5 or 6 times slower. and you take that into account, the probability drops to 1 chance in 10 to the 24 millionth power. Now that's 24 million zeros between the decimal point and 1. I hope you understand it's a very, very tiny probability. To give you some idea how small that probability is, do they have a lottery yet here in British Columbia? Yeah, they do. Well, they got one in California. You know, California's got more people than all of Canada. And so the probability of winning the California lottery is quite tiny indeed. But to get an idea of what that 10 to the minus 24 millionth is like, it's equivalent to the probability that a citizen of California will win the California lottery 3 million consecutive times where they buy just 1 ticket each time. Or as one mathematician friend of mine put it, it's the same probability of a Californian winning the lottery 3 million consecutive times where they don't buy any tickets at all. Probability is 0. Now, what Francisco Ayala had done was to prove that it's impossible for intelligent life to exist elsewhere in the universe. What he overlooked is his calculation also demonstrated that human beings here on planet Earth are impossible to explain through Darwinian principles, beginning with bacteria. The only way we could be here is if the God of the Bible supernaturally intervened in order that we would come up at the end. And actually, let me end this whole discussion with what I call the simplest argument in favor of biblical creationism. And it's based on the laws of cause and effect. And this is something every physics student gets taught, namely that effects cannot be greater than their causes, and the created cannot be greater than the creator. I mean, that's just simply a conclusion that you can draw from the second law of thermodynamics, but the Bible talks about a pervasive law of decay. You cannot get the greater from the lesser. Here's the problem for the non-Christian. How do you explain the living, the personal, the conscious, the mindful, the emotional, the volitional, and the spiritual coming from that which lacks consciousness of mind, personality, life, free will, and a spirit? I mean, how can a lifeless universe with no consciousness, with no emotions, with no intellect, with no spirit, bring about something that has all of the above? I mean, every human being in this audience is greater than the entire universe, the entire inanimate universe. Because you actually think. You have a will. You have a spirit. You're conscious. You can do things that rocks can't do, that stars can't do, that galaxies can't do. If you want to read more, check out our book, Who Was Adam, where we document the latest evidence. And I think Psalm 24:1 says it best. The earth is the Lord's and everything in it. Okay. We're going to do a Q&A time, but I always